Okay. All right. What is our agenda for day two? Um, I know most of you guys were here on Tuesday, but I'm going to quickly show you what we did, right? So the two things, remember the discussion and also the submitting files to the canvas quizzes. But before that, one of your classmates pointed me that you here's what happened, right? So, and we have this um, and you can see that this deadline for everything, right? And then to begin with, like I said last Tuesday, we don't penalize people for missing your deadline, okay? But unfortunately, so what happened is this, but we have this deadline for you as a you, for you to use as a guide, like no, I mean, this is suggested way that you should follow. And then in the end, and you see that the last one is the last day of the module. Like for example, this one, this 24th is the module deadline. And the last item is the this one, the module reflection, and also the assignment due on August 24th. So until then, there are other deadlines. Okay? So all of them for you to streamline your participation successfully, right? So we don't missing out on those. But what happens is that unfortunately Canvas, if Canvas sees that you missed it, it goes ahead and you will see it. Okay? When you later submit, that zero is still there until you manually go and actually grade it. Okay? So when you get that zero, your grade is going to hit, right? So don't worry about it for this couple of weeks. Okay? Because we are still having our TAs to grade and stuff. And I need to grade these two assignments in the weekend. And once I grade those, your grade will be perfectly fine. Okay? So think about on that. Okay? So again, Canvas automatically grade. Unfortunately, we don't have control on that, unfortunately, right? So when the sudden deadline or anything like that happens, Canvas goes and put a zero there if there's no submission. But then when you later go and submit, right? And then we get to know, okay, when we love to and manually correct your grade. Okay? So that process takes, couple of days to 1 week, let's say. So you may see a zero instead of something else in your grade. Okay? So don't worry too much about it. Okay? So we are, and also understand that we are also in the process of hiring TAs for grading and stuff, right? So those things are happening right now. Okay? So, and that zero doesn't mean that you have a zero. Okay? So we will correct that. Okay? So, and then unfortunately, Canvas doesn't provide a workaround for us instructors that, and it's unfortunately what it is. Okay? So, okay. So, any other questions like that? Like logistical issues, questions? So there's a way to fix it, but then it's going to artificially influence your rate. Okay. So, but I'll probably do that for a couple of weeks. Then I'm going to, um, doing like, let it do that the way that we have right now. Okay. All right. Any other questions? So yes. Yeah, so what you can do is actually, like, if you are in a hurry, you can go to the next one and go. Yeah, it will allow you. And you can just come back later and by car. It should allow you. So if it's actually really like stubborn and want you to submit something, submit it empty. Yeah. Get a zero for now and then go to the next one. That's what I find. Yeah, because all of these, except the executive videos, we only have three submissions. This you can take a zero and then use one submit attempt. But everything else have unlimited attempts. You can get a zero for now and then go to the next one always. Okay? So and then come back and then do it. So and then the way it's arranged that way is just to give all right. Okay. So we're gonna basically. How many of you are new today? Alright, so, okay, so we're gonna. Hmm. I directly jump into the lesson, but so I'm gonna quickly do this one. You can follow me, okay? So, but everyone else can also follow me as well. So can you open? So this is in the module one. Can you open this one? Yeah. So this is basically how to submit code and an embed pages. You can take a look what others have done, but this this tells you what to do. On the top. Yeah, going to follow this step. All right, this is what we did, right? So steps to run this example. So click on this one. All right. So don't worry about the code. We will learn this how to write this in week and up to like week 10. After week 10, sorry. So you can run it. It draws a fish. Okay. And you should download it. So this is the download button. Let's download it real quick. And also we're gonna save it. And we're gonna save it as like a new revision or new file. Don't click on this one. Okay. So new revision. Let's say. So you'll see that the URL here going to change. Okay. All right. All right. So what we need to do is we downloaded the code, right? So that's this step. So we're first gonna copy paste that code into discussion. Okay. So we're gonna copy this code. So Control or Command A inside. So select all. Right, oh, you did it already. Oh, you submitted. Okay, I thought you did submit. Okay. Oh, okay, okay. I thought you didn't do anything on this side. Sorry. All right, you can bypass. Yeah. You don't need to for now. We are not using it yet. We need to attach it to the assignment. But starting before we can run it. Um, I can teach you how to use your Python. Like, you will get that. Know how to get it. Yeah. So yeah, so you can proceed to all this. Yes. Um, anyone who is new today? Okay. So Bridget, could you show her how to submit this? Yeah. Over there. And she might need other has to needs to other needs to get going. All right. Um, yeah. So guys, this couple of weeks, it's kind of like that because again, this right? All right. Yes. Yeah, you can. Just, just warn me and about the trip. Oh, wait. I'm glad you did that. I mean, yeah, I was assuming that, you may have this. Yeah, because you are not here, right? Yeah. But just go back to the, yeah. So there's one mistake I can tell you. Yeah. So you can if you compare others. Um, see that this is formatted and uses plain text. Okay. So how do you change that, right? So this you right? Okay, this is how you edit. You can always edit your submission. Um, select all, you select all, command A. Then you see that is paragraph. So it's just plain text like paragraph. You want to actually format. That's it. Okay. Right. So it's more clear, right? Like code. Like, yes, you have to do that. Yeah. Otherwise, there's a tiny penalty, like 1 point. All right, guys. So one thing I wanted to show you before we actually begin. Um, so one place is that like when you let me go to the student view. Okay, so this you me as a test student. Okay, so and you can see that. So let me start off with this one. Okay, and you can see this always start with the module view. Okay, and then click on the thing that you want to start, and then you will see and you finish that, and then go click next button. Okay, so this is how you go back and forth in module view. Okay, and then once you are done with that, then you basically you submit this quiz and then you click next, right? Or if you going to go to previous one, you use previous button. Okay, so always rely on these two buttons to go back and forth in your module view. Okay, that's very important. So start off with the clicking module. So you get the module view and then select the item you want to work on. Finish it, go next button. You want to go back and go to previous button. Okay. So that should be your go-to way to do that in Canvas. And I don't see I didn't graded the test student, but if you go over here on grades, you will see your grades and you can see that Canvas already put zeros in missing ones, right? So and even if you submit until we manually grade, that zero will stay there. Okay, for one, we'll try our best to minimize the time to at least 1 week. Okay? So that's how it goes. Okay, so like you can see over here that you will see um, like if we provide any feedback, you'll see an icon over here to read it. Okay. So I think this one probably give you no, the rubrics. I'm not sure though. Um, yeah, I think this one. Yeah, so that you can see the details of your score and then if you have even inside to you, like yeah. Okay. So make sure it takes your grades and then feedback both automatically or manually given by us. Automatically coming your grades, manually from your TA or from me. Okay. So please try to follow those feedback and if you need a correction, follow them to correct yourself. Okay. So I'm gonna quickly give some feedback to these test students. This is not good. That's a that's a bad use case from Canvas. If you um, if you leave the student view in the grade, it will show everyone's grade to the class. That's not good. All right. So that's why I closed the tab, right? Right. Okay. So I'm gonna go back to the let's say this one. Let's put this one. All right. So again to do this, give me 1 minute, guys, because again it's gonna show you. Yes. So I'm gonna grade the test students. Okay. So in a couple of seconds. Um, it's good to show you that as well. Okay. So I'm gonna get the test student view. Now I can show it to you. All right. All right. So test students didn't submit anything. Okay. So but we can. I see that. So I'm grading the test student, right? So I have the rubric over here. So here's what we will do usually, right? So based on the rubric, we select the slots. Okay. So it's now actually graded. So if it is fully complete solution, we'll do this, right? So and you can see that once we grade, so you'll get 10 points, right? So it will actually update your grade book. For test student didn't submit anything, so I updated this and then save, right? So so this is what. So now I'm going to go to the student mode. Sorry, student mode actually. Yep. Let's go to this place and student view. Go to grades, and you should see that over here. Yeah, see that over here the feedback, and you will see the rubric. Okay. So if you click on that icon, you will see the feedback from us. So sometimes we take those words based on your work. Sometimes if it's most you will see also specific feedback from the TA or from me. Okay, so take a look on those and read those and then correct yourself if it needs. Okay, so just wanted to show you that. All right, so so let's begin. So we're gonna start our sci book, and we'll be able to finish it off, guys. Okay, so All right. So this first go over pick one or two questions and then do them. Okay. All right. So let's pick the this one. Are you guys going to tell me the answer for each one? So tell me which one to drag and drop. Okay. So my assumption is, you guys have done this already. So um, at least starting next week, right? I expect everyone to be at least half done by Monday. No, sorry, by Tuesday, and then definitely be done by Wednesday. So try to, okay? But then it will be your second time going over the things that you learn already using the book. Okay. So yeah, in learning, you know that repetition is very important. Repetition. So we repeat over here as well. All right. So first one, answer the first question. This one. Which one should I drag and drop? Yes, 1920s. All right, correct. Next one. What is? It's the ENIAC, right? Yep. Next one. 60s. This one. All right. Fourth. 70s. Fifth. Today. And the last one is most low, right? So that's the low actually. So it's still actually going the same way it actually predicting. Okay. All right. So let's go to the second one. Go to this one too. All right. Where should I drop come to the bottom? To the first one. Okay. And who coined that? Who coined the name bug? Yeah. Yeah. And short circuit in the right? Yeah. Pick the bug and reported it. Yeah. And she wrote the code bug. So that's the first reference of software bug. All hardware bug. Yeah. But bug the name bug in computer science. Who is that, guys? You must have already. Yeah? No. It's in the text. You read it. Anyone? 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 Yeah, Grace Hopper. Okay. She did that. She was an early um pioneer in computer science actually. One of the too bad that it didn't progress that way, like the way she did. Right? So and then unfortunately, computer software industry became a very dominated technical field. But early pioneers are actually a lot of women in there too. All right. So the next one. So this one, compiler. Where should I drop it? Third one. Okay. All right. International Business Machines, IBM. Where should I drop it? Second to last. Okay. It's not coming. Okay. Right here. Correct. This one, punch card. Second one. Okay, Hubble is the last one. This one, the bomb B, right? Yeah. All right. So, who invented the punch card tabulating? So that's also in who is like um, what was the you say? There's a even more earlier you say. Yeah, yeah. So what was you say? Textile, right? So you you wanted to say design the design. So that's how we design the punch card and change the pattern of the punch card and feed to the machine. Machine pick a different design. So weave the tablet. So it's looming, right? Loom. What do you call it? Like looms, right? Yeah. The textile industry kind of kickstarted the idea of the punch card, and then Babbage also used it, right? I think no, that's actually analytical engine. That's different. Sorry. All right, and then this one, um, who actually set up this one? This the World War II thing. Actually, Turing, right? So Turing that did that actually in England actually. So it was really helpful in deciphering Hitler's messages. Of course, they didn't know that actually, so that was really helping the Allies. All right. So we're gonna go to the next section. So again, we're gonna answer some of these questions. So let's pick the one that second one. So pretty much, I'd say many electronic devices use a chip inside. Even TVs are kind of specialized computers these days. That's true. And by the way, guys, so when you progress in Cybook, it's actually gives you really good feedback. So even though it's correct or not, take a moment to read them. So please, definitely when you get it incorrect, read it. Correct one also has a good feedback. Okay? So we're gonna go into this topic. So we're gonna spend a little bit more on this one. Okay. All right. So before delving into this topic, okay. So let's talk about solving a real world problem. Can anyone um, suggest an example, a very simple one? Any idea? You can see it over here, right? So can you see this one? Okay. All right. So let's say I want to go. Imagine uh, we don't have GPS technology, no apps or anything. So what did we use? If anyone of you of you use, so go back to like 90s, maybe early 2000. What did we use from go from city A to city B or address A to address B? Map, right? So paper map. Okay. Unfortunately, the industry went bankrupt after the GPS because the printing happened industry actually went bankrupt, right? So anyway, what are my inputs? So this is a problem, right? What are my inputs?
Your location where you are, your study point,
Yeah.
and your final destination.
Yeah. Where I want to go, right? So these are the two inputs, right? So inputs, um, I say location A. Could be an address, could be a you have a map and you know where it is, right? A and right. Okay. And then basically to get here, I have to figure out how to, right? So visualize in the map, right? So basically the, the route, right? So, so basically this where I want to go. So the output should be so again guys is not still not a programming problem, the real world problem. Okay. So output is reaching B, right? Okay. So right here is the process, right? Or the solution, right? That we have to come up with. And then you have to find the it could be like optimum route that that it would take from A to B, right? So there may be many routes, right? So we have to figure out okay what would be the easiest or shortest path. That require processing other knowledge as well, right? For example, um, if it take if it take 101 in the restaurant, that would not be a optimum one, right? So we may have other easier, like like through AVD, like less traffic routes, right? So those decisions also need to go in there, right? So there are a lot of decision making over here in designing the solution. But we in the end we finally come up with actual route. Okay, this one we make a right here and then enter to A here and then right likewise. All of it. So one thing to note is that this solving this problem from going A to B, you have many solutions, right? Right? Yeah, you can take bus, you can walk if it's short, right? There are many solutions. And you can think of that, okay, for a single problem, there may be more than one solution. Okay? And again, depending on the need and depending on the way we implement, right? Okay. So that means basically a single problem may have many algorithms that solves it. Okay. And if you want, you can now write the steps you want to follow, like turn by turn directions, we'll say, right? So you can write them down as well. So you can think of them as the algorithm of our solution. Okay. The steps that we take to solve the problem, in this case, from getting from A to B, right? So this is a real world problem, and you can see these key unique things in real world problems. What are the three things? We just went over all three of them. Input, right? Second, output, and then the solution, right? So basically, input, and we process the input and design our solution, right? And then come up with the output. So these are these, and if you think of, I mean, we don't philosophically think about problem solving per se, right, in real life, right? But every moment, we solve a problem, right? We take an input and process it and do something, right? Every moment, right? So it's really very real. So I mean, we don't care about that. We don't think about it in that way, like philosophically, right? But in computer science, getting into that and understanding that process is very helpful for you to solve problems in computer science. It's a similar process that we take in computer science. So, and this is that thing, right? So in computer also in programming, we do this same thing, right? We have an input, we process that input and design our solution, and then we have the output, desired output. What if we don't have the desired output?
We need to double check the solution.
Yeah, we basically, yeah, we correct ourselves, right? So we evaluate our algorithm, right, or the process to correct ourselves, right? And you can see that, believe it or not, in computer science, that process probably takes several iterations to get the solution correct. So you need to sort of kind of a foster a habit on that as well, right? And we will get into that more on that in the interval. What the video on that, okay, today. But yeah, so that's the basically so we have a problem, we solve it, but the solution was wrong. We go back and go both in cycles and correcting also. Sometimes it may take a while to get there, right? Especially in coding, it usually takes several iterations, even for an expert, to get the correct solution. So we have to kind of foster a patience on that. Okay? So don't give up from the get-go if you don't get the answer, okay? From one or two attempts. Maybe take like 10, 15, 100 attempts, okay? Depending on how complex the problem is, okay? All right. Okay, so that's this one. So we can answer some of this concern. If you play this animation and it can show you a simple problem of values x and y, and the output is printed to the screen. So and problems can be complex as well. So and you can take again. What we do in Melbourne, and here's an example of how to make a chocolate chip cookie, right? I wish they should have numbers there. So, because we follow a recipe means we follow numbers of kind of steps, right? So that means basically I should have been say 1, 2, 3, 4, my opinion. But it's again showing you how to bake. It's exactly like really analyzes to that. So real um, solving problems in computer science really close to solving real world problems. So it's like a recipe. So you can say this is synonyms. So yeah, you will encounter them as we go on. You can say this is the algorithm, this is the recipe, this is the plan, this is the design. All of those are synonyms. All right. So let's answer this one. So let's basically I'm gonna quickly play this one. So it's a simple program. Okay. Um, all right. So m is 5. So this is not Python, guys. So don't worry about the code. All right. So so we have the final output 115. Okay. So and it's asking execute this program to observe what's happening. Okay. And then we can answer some of these questions. Okay. All right. So let's do number 2. Which instruction completes the program to compute the average of three numbers? Which one? First one? First option. Yeah. Okay. All right. Okay. So we're gonna get into this one. All right. So any question so far? Any opinions? Any comments? Any statements? And why we need to so um analyze how we solve like normalize I would say how we solve real world problem in coding too in software world too. Why we need that? Why we need to have that analyzed? My question is um, like, we don't think about okay this way of analyzing like how to solve real world problem, but having a good picture of understanding that is really important in software world. Why? Simple reason. Yes.
Well, I see like a real world example of trying to find cure.
Mm-hmm.
So I'm like trying to optimize it,
Mm-hmm.
figure out the best way to do it.
Mm-hmm.
Um, and, the thing is that I want to be able to do it quickly, figure out the time. And presumably with a computer program, you're trying to, get the solution that is not
Yeah.
time.
And yeah, so by using an example, for example, if you use Google Maps and then choose bike option, and Google should do that the same, right? And
Sometimes they don't make them.
sometimes they don't. Yeah,
Yeah.
you're right. So, but Google has to. So, hello, what real biker does, expert biker does, is giving it an instruction, right? So that indicates basically in software world, in programming world, we solve real world problem, right? That's one. That's a simple reason, right? And that's why basically Google engineers to think, okay, have to think, okay, so I need to find the optimum path programmatically to get to from A to B, right? So, and if you have a physical map, we know how to do it, but Google had to do it using code, right? So, and then so algorithm actually came like once guys started asking them who can actually explain that the shortest path problem. If you think of that other name is also we call traveling salesman problem. So if a salesman travel from city to city, and you have to pick there's a way to pick the shortest path that you can extend cover all the cities. We call it traveling salesman problem. So something like that actually. So that's an actually algorithm. Actually, real scientists in 60s came up with that algorithm that Google and all those mapping people still use it, right? So, and otherwise, there are many ways to go from A to B, and you may not pick the optimum path, right? So we have to make sure that we have the optimum path. Considering all the inputs, like there are other um, restrictions too, right? So if you want to avoid tolls, you want to avoid common um, those things as well, right? Okay, so basically think of this, right? So it's really important that you analyze that and understand that philosophically because in programming is so real. All right. So, all right. So I think we can finish this one. Maybe we'll need a little bit more time. Let's see. Okay, so in the information age, so this process of writing code to solve problem, it's, um, we call it like computational thinking, and then and it's basically coming up with the algorithm or the solution that solves the actually think computationally, um, and then how to mitigate that. Okay, so it probably comes in week 2 or week 3, and we're gonna learn a technique on that. Okay, so any questions? We can actually start from this one after the interval if we have enough time. And by the way, guys, we're gonna finish chapter 1 today. Okay, but it's a shorter chapter, so one day is actually enough to finish. But chapter 2 is you'll see that there are a lot of subsections in there. Okay? So starting today, I would say get on with the chapter 2. Okay, so so that you're more than halfway by the by Tuesday. Okay, so at least. And by Wednesday, definitely you probably should have done challenge activities as well. Yeah, so good. Yep. Yep. So that we can spend a little quality time on learning that topic in the two actually. Binary number system, which is everything in the all of you see all of these are zeros and one in the end, right? So you're gonna learn about how that comes. So it's a little bit technical, okay? So we need more time. All right, so let's get our brain guys. Okay, so be here around 11:06. Okay, and we're gonna watch a video on growth mindset. Okay, um, so yeah, I think that, yeah, I can really sit down and this hour. Yeah, it's gonna be Friday, but I usually yeah, 9 to I put 9 to 10 I think. But this Friday I'm not available in the morning. So I'm gonna announce the class the time the time. So you can jump in just a couple things and also you can email me and we can set up a different time. Okay. Mhm. So these are my examples, right? Yeah. So and then these are the respect to decimal values. So this is the binary zero is this is the basically the decimal correct to decimal value in the game. Okay. But these are the like if you think of like the way we write numbers is from um, right to left, right? Yeah. So one can put one over here, right? So one, so decimal value was this one. Right? So this is the one for 0 position in the in the scale, and if you put one more, this is one in binary three actually. This yeah. So yes, that okay. So but we're gonna this is a good observation, but we're gonna really in detail go on Tuesday. Okay. Don't worry too much. Okay. Yeah, but we can also discuss on Friday. You want to do it today, right? Okay. I know that. Yeah. Oh, okay, nice. Okay. Thanks for insight. Yeah. So, yeah, so this since you are new today, you need help. Um, do you have Canvas access? Canvas access? You just log into the course. Okay. Um, okay. So, the notebook because yeah, computer science class needs a notebook. Okay, okay, go to your canvas. What's your name? What's your name? Vanessa, I think if you raise and after the class, I can show that as well. But you go to the my room and yeah. Get a break and come back, guys. Okay. Okay. So, uh, that okay. I also asked from the department but I'm glad you. That's fine. So you are there now, right? Oh, yeah. Can explain that. Okay. Yeah. Go to canvas. Yeah. Yeah, so basically, so this is the way that you have to follow. This empty circle means you have to read that page. So you have to basically get access to this one, you need to complete this one. So maybe you go top down. So don't worry too much about like getting the job design or anything like that. So this is just all of these are just pages. Okay, just pages. So you can just simply read them and then but you can access in between as well. So um, simply go over this and then you get access to. We are not right now doing chapter one. Let it go because this is not complete yet. So yeah, so quickly basically review these pages. You don't need to. I highly recommend reading them, but if you are in a hurry, you can simply go down and click next button, and you can go back and forth between these two buttons. Yeah, yeah, definitely I recommend it. And this is the side book. So now you can actually. So this is not you, right? So people don't log out. That's why. So click no. Then, yeah, then you have green card now. So you need this book actually. Yeah, so you need to buy this one for okay. Because this book is required, otherwise you cannot pass the class because part of the marks coming from the book. Mhm. Mhm. Okay. Yeah, you can do that. Yeah, yeah, it should work. You have something like a credit card or something like that? Yeah, use that, please. You can do it right now. Yeah, you can do it. And section for this class is student section 005. Okay. Previous class is 004. This one is 005. Okay. By the way, guys, the section number of this class is 005. Okay. And probably for you guys, I might probably pick that. If not, I can also do that. Okay. I completed the previous class. So they all have now section number 004 inside this I'm talking about. So you will have 005. Oh yeah, yeah. Oh, okay, yeah. Even this class too. Yeah. Oh, you are in the 8 to 10 class, right? Tuesday 8 to 10 or 10, no, no, 10 to 12. Okay. No, no, I told you. I think I got it wrong. Sorry. No, you're good. Yeah. So yeah. So yeah, you're right. So you guys can get together and partner subject for me. Okay. All right. All right, so let's watch this. There's one more missing over there, I think. All right. So this is the one that guys. So you all, especially in this subject, you need. So it's just. So I just published it. So refresh your module view. So it's a 6 minutes video. So let's quickly watch it. And yeah, no, module one. Don't worry if you don't worry if you don't have access. It may block you. Um, Otherwise, you are good to go. Could you turn off the? So imagine this one. So we're gonna go into this one. So this the idea of the travel with the pen. Okay. So we're gonna remember you guys saw the fish curve, right? It was written by the turtle, or the turtle, because the famous technique. So and then the same thing over here in the side book too. So imagine there's a turtle on the whiteboard. Okay. Um, all right. So this is the whiteboard, and then there's a turtle. Right, I'm going to go on. So it's kind of walking, and it has a tail, and then there's a pin attached to the tail. Okay. You can actually lift the tail and then up and down as well. Okay. So it's like this. So it's now the tail is down, and then as it moves, it's going to draw a line, right? Okay. So that's the idea. Okay. So the tail can move forward, backward, and also yeah, move forward and backward in any direction. Okay. And also it can actually turn left as well. Left turn. All right. So now imagine we're gonna ask this turtle to draw a square. Okay. So where do we begin? So we're gonna attach an algorithm to do that. Yes. Right forward. Okay. Yep. So yes. So the algorithm is step one and down. Step two. So we kind of missed one point though. You are correct. But let's say I want to draw square with 100 units aside. So what is that?
Well, 100 units is distance.
Yeah, so what is that? That we just learned, right? What's the conceptual name for that? You want
Oh, the solution.
no? So we want to draw a square with 100 sides, pixels, units, inches, meters. Input, right? That's input. That's okay. So the problem is okay. Draw a square, 100 each side, right? Size of 100. Okay. So I think the first step should be to collecting that input. Okay. So I'm gonna change that. So one is input, put length. Two is yours. Pen down. Okay. So pen down. Step three. If you want to figure it out by yourself, before this, one good thing that you can do very first. So imagine this is your turtle's pen, and you draw it by hand, right? So start off with like this and move forward by 100, right? So 100. Then to draw the next side, what do we have to do?
You have to turn.
We have to turn by 90 degrees, right? So turn by 90 degrees. Now that it's looking at this way, now we can proceed with the 100, right? So 100. What do we do next? Turn again, right? And then go this way, turn again, then and we have the solution, right? And all we have to do now is we elaborate what we did over here. That's our algorithm. Okay. So pen down now. What do we do?
100 units.
Move forward by 100, right? So I'm going to use shorthand, guys. Okay, by 100. Okay. And then 4 is turn left, right? So left turn by 90 degrees. Step 5, move forward again, right? By 100. Step 6, turn left again by 90, right? 7, so we're going to do this, right? So move forward by 100. And then last step, I think this 1, 2, 3, one more, right? So step 8, again turn left, right? Turn left by 90 degrees. The last step is going to be move forward by 100. It's always move forward because once you turn, you are looking the direction that you want to move. So you move forward, right? All right. So this is the algorithm. Okay? And no code yet, right? So we're gonna convert this to code in week 4. So we're gonna see that in the animation also we can actually pick this one in the book. Okay? So let's do that now. So we come up with the algorithm. Okay, and this one you can see that if we run this as it is and draw a triangle, if we draw a triangle, yeah. So, but we're gonna change that. Okay, so you can see that, and you can see the algorithm over here, and move forward, left by so it was over here earlier like this, and 120 degrees, and then repeat the. But we're gonna change that. Okay, so I'm gonna remove all of these, and you guys gonna help me write this. Okay. All right. So print down there. Let's step two, right? So the input you will see that will, when we click every button, it will ask for the input. Okay. All right. So next step, forward, right? By 100. So this is where we are giving the input. Okay. So that step is there, and then you can also in this tool, you can check whether it worked also, right? So you can simply run. I will draw a simple line. So you can go as you progress as well. So now we what do we do now? Step, yeah. So turn left. So the step I think 4, right? So by 90 degrees, right? So now move forward by 100, right? And left, right? Again. So we're kind of repeating, right? So if you think of want to like, right? So and then next one is again forward by 100, then left by 90 degrees. So how many left turns? Now one move forward. That's it, right? There you go. Okay, so if you so we can test it out. Yeah. It's actually the program is running. Okay. So these are not actual code. This is code. You can imagine this is code in English. So this is the text in English. We're gonna inside the code, we're gonna convert this to actual Python code. That's coming in there. Okay. All right. All right, so that's that. So you can see that like it's a nice way to um, interpret what you code into visually. That's something you can see, right? That's the good learning opportunity, right? Because usually when you do things in coding, sometimes you don't see what's happening, right? If you can see what's happening, then it gives you a nice feedback, and you can visualize what you want to do, right? So that's a good learning this. Okay? So that's actually it's educational thing. That's a module. I think for the few few weeks, um, we regularly use that to practice what we learn in the class. Okay? Python turtle package. So visually, we're gonna illustrate what we're gonna do using like a simple shape like this square. Okay. All right. So we're gonna move on to the next one. And then this again, you guys should read this one. The conceptual page. It talks about the careers in computer science and then things like that. Okay. These are probably the US averages, but the values here is way more than this. Okay, so Silicon Valley values are, I think, starter would be 120K, okay, for a um, software engineer. Okay. Um, all right. Um, so let's try to do that. So you guys gonna help me? First one, computer support specialist. Okay. Second, I need others answers to software developers. Okay. Anyone else? Opinions? Computer program. So this one. All right. Fourth, system. This one. Okay. Oh, let's check. Yeah, that's incorrect. That's fine, right? So you can always recover, right? So this one goes to where then? Yeah. And I think the web developers. This one is this system analyst. So there are a bunch of careers in the tech industry actually. All right. So read about this stuff. Okay. Okay. All right, and this video actually we're not gonna watch it right now. But watch it, you can see that software bugs are actually real, and because of the bug and this system, this firework system um, got messed up. Okay, so that means software can create disasters too. There are really good examples of that. Okay. All right. And probably we'll watch a video in a future class on one of such disasters. Okay. All right. So we're gonna go into this one. All right. So we're gonna talk more about comprehensive thinking, and actually there are four major concepts in there. So often the problem we are going to solve will be a complex one. So it's good to um, step by step, right? So that means you break the problem into smaller, much easier problems. So we call it decomposition, right? And then as we move on, we will learn actual techniques to do that, okay, in this class. And then if there's a pattern, say there's a pattern in that one, drawing the square, can anyone recognize the pattern there? Yeah, turning, going forward and turning left was repeated, right? So that's the pattern. Okay? So recognizing those kind of patterns you require practice, a lot of practice, right? And you will actually gain those kind of practice in this class. Okay? So you will see that you will regularly improve as you do things in the class. That recognizing those kind of practice and then coming up with the solution. Okay? So yeah, so that's actually called pattern recognition. Okay? And then the next one is the algorithm. Okay? We already devised the one, right? So that's the algorithm over there. So basically, one has to make sure that the algorithm is correct. Otherwise, not going to solve the problem correctly. So, and then, is there only one algorithm that solves a problem? No, there could be many. Okay? So, all of those may solve that single problem correctly, right? So, there may be just one algorithm, but there may be many as well, many correct algorithms. All right. So, an abstraction basically once you solve your problem, and then you should think of okay, so how can I solve similar but little bit different problem, right? So, for example, right? So think of the microwave, right? So what problem does the microwave solve? Cooking, right? Right? But imagine I'm the engineer who designed the microwave. If I design the microwave so that I can only cook pasta, would it help? No, right? Useless, right? So you create a instrument and you can only cook pasta, and that's not good, right? So that's why microwave can warm food, defrost, cook other things, right? There are a variety of things, right? So that's the generalization of the cooking something into many things, right? So that's we call abstraction. So we solve a problem, we generalize it to solve uh, related but different problems. That's called abstraction. And we learn techniques in this class as well in how we do in software. This is a big deal in software in this abstraction. Okay? So generalizing your solution to many contexts. Okay? All right. All right. So let's answer this question. Let's say number two. What's the answer? Okay. Yep. Okay. So basically, if you read it again, when the outermost number 1 and 100, then the next outermost number 2 and 99, right, and so on are added, all such sums 1 plus 100, 2 plus 99, 3 plus 98 have sum 101, right? So that's kind of authentic to recognize in a pattern because every chaos, when you sum up, it gives the same answer. That's the pattern. Okay. All right. All right. So last step, last section in this chapter is collaboration. Again, it's a conceptual topic. One of is actually software collaboration, and then there are many tools on that. And then one is actually for in regard to program version control system, we have this very the right now in the industry. And I'm going to have one project in the that you guys can consider. Okay. So I'll teach you how to do simple things in GitHub. Then you can pick your own simple code and publish it. Okay. So in GitHub. But that's optional. You can pick up among other things. One topic could be GitHub in the midterm. Okay. All right. That's it. So we are done the chapter. Let's go to our problem today. So this is we have like just 20 minutes should be enough for this problem. Okay. So it should be fine. So before that, I'm gonna go over the two things that you had, or three things. Right? So some of you already did this computer history and you, but I'm gonna quickly go over them. What you need to do. Okay. So yes, here are the instruction. Right. So your first submission, the first reply will be 8 points. So you basically need to select the year you were born and see what invented or introduced that year. Right? So it's one of the highlights of that year and write a sentence or two on how that information affected your life. Okay? So not that difficult, right? So I've seen many iPhone, right? iPhone and computers. There are many examples, right? And then once you submit yours, you will see what others submitted. Make one reply. That's it. That's your submission. Okay. That's your Yep. Oh, it doesn't matter. Yeah. Yeah. So, yeah. So, could be a good way to think. That's a good question actually. All right. So and then any question on that? All right. Some of you already submitted. I saw that. Um, all right. And then it'll open you the assignment. So we're gonna get a good practice today on doing this. I usually tend to do that. Like I design some of these discussions in such a way that doing this is going to help you doing this one, this individual one. Okay. So so let's so that will be a good practice. Okay. This one is a survey from the department. You guys should submit it because it's an opinion survey. We want to get this input from students so that we can design our programs better for the department. Okay. And you have to submit both of all of these are actually due 24th. And then this one, unfortunately, I couldn't explain this to the previous class. This one is your reflection. Okay. So module reflection. Okay. By the way, there's an going to change the historic thing and indicate that. Like, change it should be good. I changed that. Don't worry. But this basically a survey, graded survey. Okay, so it's your reflection. Okay, so when you reflect after completing the module, what happened, what went correct, and what went right. So it's a really by research proven method. The one way to, one great way to learn something. Always reflect yourself and correct yourself after the reflection. At the same time, you will also give me feedback as well. All right. So honestly, please honestly do the reflection. You didn't do something, pick correct that I didn't do and then explain. Okay. All right. So that's that, and then yeah, and that's it. Okay, so you'll get the access to this once you do those things. Okay. So don't wait too long, guys. So this requirement prerequisite will block you if you don't complete module one. And it's again for your own benefits. Okay. I know that for some of you it may be frustrating because you don't have access, but it's not a good discipline to jump here and there and do things in the past. So okay, let's go over this one now and finish this one for you. Sorry. Um, how to open it? All right, I just published it. So you're gonna basically write a recipe, not code, guys. Okay, uh, on how to make a smoothie. So you're gonna solve this problem, how to make a smoothie. So pair up. There are thousands of ways to make smoothies. Think of one and then, or design a one and then write down. Okay, and I'm gonna follow the same way what we did to access the things, but here even though it's so you should replace this line and start off with code comments, okay, because these are not code, English. So we're going to use a similar platform, the same platform, and doing this. Okay. All right. So shall we pair up? Find the neighbor or find the same neighbor that you found the other day, and we're gonna formally create groups. Not today. Sorry? Oh, it's actually uh, yeah. If it does, you want then you can write it down. It's actually the oh, we have refresh. Yeah. So the instructions are there, guys. Okay. So and also we have a new result. Yeah, guys. So again, I, I, I insist, okay, tell up and do this, and you might say this one is simple, all right? But thank you for asking like that. Yeah. So and you might say that we're gonna get into more complex problems, okay? So that's extra. Oh, for the movie one. Oh, this is a really good question. Yeah. So just make sure that someone totally new can understand and do it. That's it. That's enough. So you don't need like okay, open the page and you don't need to go that far. That's too much detail. But just make sure someone else can read and make it. Again, that is the end of the so make sure you have one again, it's a coding platform, but we can stick with the support comments, okay? So just like it's up to you. If you ask them is complete, that should be enough.
Yeah,
But
yeah,
if
that's
you
what
agree to one thing, then one thing, that should be enough for a small group.
numbers that in play. So we don't
Yeah,
even if like that,
the way you make it, it's fine.
very detailed. Yes, that's what. Oh, yeah, no, that's what
Yeah, so that's basically like you click on that way, you go to the coding platform, right?
yeah,
We are not coding yet. It's just coding something. The common sign comes right.
and it takes it as notes, not.
Yeah, it's just not.
Yeah,
Just
that's
running.
yeah. So that's what I'm trying to do.
Yeah.
Use the pound
So
sign.
for example, if you put common sign, so this one is calculated. Yeah. So common sign
That's what I was trying to figure out. Yeah, yeah.
so yeah, we also need the sorry, I didn't invite me, but I was stuck with my daughter.
Forever.
And you also make
So,
you know,
like,
sometimes
okay,
they say
makes sense that gather. I was just gonna write gather pre-cut, right? Because you just said cut and paste. Okay. But there's another way to do that. That so if I, that's why I was trying to start by saying, okay, gather pre-cut and gather. Yeah. So like just gather. It doesn't matter what it is. You're gonna gather the pre-cut and prepare. Sure. That way it kind of cuts everything else. Because like you were saying, if somebody that would never done it before, right? So maybe somebody new to restaurant. So, you know, when you go as far as to say pre-measured package, and
that sounds good.
literally at the restaurant, like, yeah, it's like it's a
Tell
pre-measured
them
package, go to your
how did
pre-measured
you apply,
package,
and then
dump it in,
once you have
and
done,
then
this
the
is the
liquid stuff, right? So, I just say, okay, there's a pre-cut package of fruit. One of those is liquid, right? So, liquid.
you know, daily examples,
You know,
because
what
there
else
are
does
some
fruit
others
smoothie
who
is
have
like
done this.
fruit smoothie,
Otherwise,
like
why
three,
to do that? Yeah.
and then put those in the blender. Um, push option one on the blender, assume and wait
Yeah,
10 seconds while it cleans up and pour in large cup sugar. Like
So you are transferring after this four, right? You too, right? The other, how about you? Okay. Yes, yes. That's what it is. Yeah, engineering program. Yeah, it will take some money. And but you also know that UC is expensive, right? But you know, you had to the last mile. They did not know. You know, if you apply, you definitely apply now because CPI, uh, 10 students, all girls, better. Although not all girls, because they prioritize girls. That's one of the reasons they give you 500 something, right? Oh, wow, okay. Congratulations, right? So, because they, because you are going to ask for program, right? If it's an RU, then they sorry, if it's an RU, they pay up to 10,000. So, how much did you get from them? Okay, so 1,000 they but I think next. Oh, yeah. Okay, so he's going to have but this time they really apply. This time they prioritize women and they have to yeah, that's why getting good. So we had a girls and four boys getting 2,000 dollars. There's one because as a CPI, we have flexibility. Kind of, I got to know that. So now they know. So they now asking for this year. Oh, okay, yeah. Please do it. Okay. So, even then this time they will not use it. I only have 40 hours. So I had 80 with you, right? So this time they will use it. But tomorrow, they have yeah, yeah. Okay, so when you see that, if you get that here, you're done basically, right? So, okay. No, no, I'm not actually saying. How's it going, guys? All right, guys, it's 2 o'clock, okay? So, Professor Craig named the class now. So we have to go outside. Okay. All right. So get it done. Let's say tonight or this week. All right. And if you need me after the class, just find me outside. Okay. And we can go to our room for 467.